Cool. So today we're going to understand the basic mathematical formulas for computing mathematics, and that is the main learning objective for today's session. So basic mathematical formulas are essential tools in computing, forming the foundation programming logic. One second, guys. Forming the foundation programming for programming logic, data analysis, algorithm development, graphics rendering, and system design. These formulas allow developers and engineers to perform calculations, model problems, and generate solutions with precision and efficiency. Understanding how and when to apply these formulas is vital for developing effective computing solutions. Arithmetic formulas. Arithmetic is the most fundamental area of mathematics used in computing, supporting operations like addition, subtraction, multiplication, and division. These operations are embedded in most programming languages and are frequently used for calculations, loop counters, and indexing. So there's key formulas such as average, which is also known as the mean. This is the sum of all values, or the number of all values. Sorry, this is the sum of all values divided by the number of all values. That's what I should say there. So number of values. So then, for example, if there are four numbers and it's 2, 3, 4, and 5, for example, you would add 2, add 3, add 4, add 5, which equals 2. Let me just do that. That's 14. And then you would divide that by 4 because there was 4 numbers there, 2, 3, 4, and 5. An example in computing is calculating the average user rating on a website using values stored in an array. Percentage formulas are used to calculate proportional values, which are crucial in financial calculations, user interface adjustments, and progress tracking. Key formula for this is percentage, which is part whole times 100%, which is part whole times 100. Sorry, don't know why it said it twice there. I should say it once. An example in computing is progress bars showing percentage completion of file download or task execution. These for area and volume formulas. These formulas are especially important in game development, simulations, and graphics, while spatial calculations are required. Key formula: area of a rectangle equals length times width. Volume of a cube equals area cubed. Volume of a cube equals a cubed. Where a equals the area. An example in computing is calculating space occupied by 3D objects in a simulation or determining screen layout in UI design. Geometry and trigonometry formulas used for angles, distances, and movement in 2D/3D spaces. Geometric and trigonometric formulas are vital in animation, robotics, and augmented reality. Key formulas again here is the Pythagorean theorem. This equals C, which equals a squared plus b squared. Trigonometric ratio. So this formula could be sine theta, which equals opposite hypotenuse, cosine theta, which equals adjacent hypotenuse. Sorry. So yeah, so that's it. I don't know why these are so messed, guys. Sorry about that, but yeah, it says. Example in computing is calculating the distance between objects in a game world. or determining the angle for rotating an object in 3D space. Algebra provides a method of formulating and solving equations in computing. Variables and equations are used to model relationships and perform operations. The key formula for this is linear equation, which is y equals mx plus c. An example in computing is used in machine learning algorithm for linear regression, where y is the predicted outcome, m is the slope, and x is the input value. Logic and Boolean expressions, though not numerical, logical operation based on Boolean algebra, are mathematical in nature and are crucial for flow control, decision making, and digital circuit design. Key expressions and or not. Example: A and B, A or B, not A and not A, not A and B, A or B again, and not A. Sorry, that's just repeating it. So yeah, so this sign here, let me see if I can annotate it. Yeah. So that sign there is not. This sign is or, and that sign is and, guys. So an example in computing is used in if-else statements, loop conditions, and decision-making in AI systems. Probability and statistic formulas. Statistics are used in data science, performance monitoring, and decision systems to understand trends and make predictions. Key formulas. Mean equals mu, which is 1n. I equals 1n times I mu, and which equals n1. Yeah. Standard deviation is here also the formula for standard deviation. So that's the sign for standard deviation again, guys. That's for standard deviation, which equals to 1n. An example in computing is assessing server response times, predicting customer behavior, or tuning machine learning models. So here's a summary of the table. Here's a summary table, sorry, of the basic mathematical formulas in computing that we just discussed. Again, it's just repeating what I just discussed before. Arithmetic at the top. The formula is mean equals sum divided by the count. Which and the application in computing is calculating averages. Percentage, again, this is part divided by whole times 100. That's how you usually work out percentages in mathematics. And then the application in computing is displaying progress bars, discounts, and performance metrics. Area and volume, so area equals length times width, and volume equals area cubed. This is used in game development, UI layout, 3D object space, geometry and trigonometry. So Pythagoras equals C equals square root of A squared plus B squared. And for trigonometry, it's sine and cosine. And this is used in positioning, angle movement in 2D and 3D graphics. Algebra, which is y equals mx plus c, and this is used in data modeling and prediction algorithms. Logic and Boolean, so this is A and B, A or B, and not A. This is used in programming control structures and logical decision. And finally, statistics, which is mu times x divided by n, and then the formula for standard deviation here, which is square root of x minus v squared divided by n. And this is used in data analysis, machine learning, monitoring system behavior. So the conclusion here is basic mathematical formulas are embedded throughout computing, for simple arithmetic and user interfaces to statistical analysis and artificial intelligence. A solid understanding of these formulas enhances a developer's ability to write efficient code, process data accurately, and solve real-world problems through software solutions. These formulas not only provide the tools needed to solve problems, but also faster logical thinking, which is essential in every area of computing. So the next topic is explain the use of the following within formulas: addition, subtraction, multiplication, and division. In computing, mathematical operations are fundamental for processing data and solving problems. These four arithmetic operations, addition, subtraction, multiplication, and division, are widely used in formulas across various computing applications. They are essential for handling numerical data, calculating results, building algorithms, and making logical decisions in software systems. Addition. So addition is used to combine two or more numerical values. In computing, addition appears in formulas to calculate totals, accumulate scores, update counters, or combine variables. An example in computing here, we can see the code in Python, which is total price equals item price, add tax. Common use cases are adding items to a running total, for example, the shopping cart, incrementing a counter in loops, combining values for sensors or user input. In algorithm, in a for loop, addition is used to increment the loop variable. For example, we can see here in JavaScript for int I equals 0, I is less than 10, I equals I plus 1. So for every number of the loop will start on 0 and then it'll add 1 to I. So it'll be I plus 1, I equals 1, I equals 2, and so on until it gets up to 9 because it says less than 10. Subtraction is used to calculate the difference between values. In computing, this is applied when reducing quantities, comparing values, or determining changes over time. Example in computing is remaining balance equals account balance minus withdrawal amount. Common use cases are calculating time differences or date intervals, determining loss, decrease, or reduction, checking if a limit or threshold has been passed. In algorithms, subtraction is often used to calculate the distance between two positions or timestamps. Multiplication. Multiplication is used to scale or repeat values. It appears in formulas involving area, scaling graphics, calculating interest, and determining total based on quantity. An example in computing is the total cost equals quantity times unit price. Common use cases are calculating percentages, for example, discounts on VAT, repeating patterns or animation in graphics, resource allocation, which is memory blocks, time size. In algorithms, these are used for exponential calculations or performance scaling in machine learning and game physics. Division is used to split values in equal parts or to determine ratios and averages. It helps in balancing resources, calculating unit values, or converting units. In Python, an example is here, so average score equals total score divided by the number of tests. Common use cases are calculating average and mean values, converting between units, so bytes to kilobytes, and splitting workloads in parallel processing. Division is used in normalizing data or adjusting time-based metrics within algorithms. So here's a summary of the table used for arithmetic operations and computing values. Is literally what I've just been through. So yeah, I'll give you a minute or so to have a look at this and then we can move on.
Yes, Mr. Hamza, we're done.
Cool. Let's move on.
Hello.
The conclusion is addition, subtraction, multiplication, and division are core components of mathematical formulas in computing. They serve as as the building blocks for data processing, logic flow, and algorithm development. For calculating totals in shopping carts to determining animation speeds in video games, these operations play a critical role in the functioning and reliability of computing systems. Mastery of these arithmetic tools ensures precision, logic, and flexibility in programming and problem solving. the next the next section of this of today is explain the functions and equations used for calculation. In computing, functions and equations are essential tools used for performing calculations, processing data, and building algorithms. Functions are reusable blocks of code or logic that perform specific tasks, while equations are mathematical expressions used to represent relationships between variables. Together, they form the core of computational thinking and enable accurate and efficient data manipulation in software systems. Understanding how to apply different mathematical functions and equations allows developers, data analysts, and engineers to automate tasks, perform statistical analysis, and build applications that solve real-world problems. Mathematical functions are predefined operations in programming and computing environments that take input values and return computed results. These input values are also known as arguments. These functions are found in nearly all programming languages and are used for a variety of tasks such as rounding numbers, calculating square roots, trigonometric evaluations, and handling statistics. Common types of mathematical functions. So abs x returns the absolute values of x. For example, abs minus 5 would return 5, and this is used in error measurement. Round x, so rounds a floating point number to the nearest integer. An example of this would be round 3.7, would round it up to 4, and this is used in UI displays. Square root x, this returns the square root of x, and an example would be square root of 49 would return 7. This is used in geometry and physics. Power x, y would return the value of x raised to the power of y. So power 3 would be 2 cubed, which returns 8. And this is used in cryptography. Max A, B would return the higher of the two values. So max 1020 would return 20. And this is used in decision logic. Min AB is the opposite, and this would return the lower of the two values. And min 1020 would return 10, and this is used in comparisons. Sin x and cosine x is trigonometric functions used to calculate angles, and this is used in 3D modeling, animation, and simulation. This can also be put in a calculator to work out values for sine and cosine. Equations are mathematical statements that define the relationship between variables using arithmetic operators, addition, subtraction, multiplication, and division, constants, and functions. In computing, they are used in algorithm development, data modeling, machine learning, system analysis, and graphics. Common equations and their applications, so area and volume equation used in graphics, spatial analysis, and geometry-based computing. Area of a rectangle equals length times width, and volume of a cube equals a cubed. Used in UI layout calculation and 3D object modeling in gaming engines such as Unity or Unreal Engine. Statistical equations, so this is used in data analysis, performance tracking, and machine learning. Mean is the average there, and it shows the formula. Standard deviation is 1n, and application. This is used in performance monitoring, for example, average CPU usage, and for evaluating the accuracy of machine learning models. Linear equation is used in financial modeling, forecasting, and graphics. Equation is y equals mx plus c, where m is the slope, x is the input, and c is the y-intercept. Application is used in linear regression analysis, motion in graphics, and calculating rates of change. Pythagoras theorem. This is used in spatial calculations, distant measurement, and gaming environments. Equation is c equals a squared plus b squared. I think actually this should be c squared equals a squared plus b squared. So c equals square root of a squared plus b squared. The application is determining the distance between 2 points on a plane in navigation systems or game environments. Centered equation is used in dashboards, progress indicators, and user interfaces. Equation of this could be part divided by whole times 100. And the application is showing progress completion in download bars, budget out calculations, or analysis report. Again, this is going through, I don't know why this is repeating again, because we've done this, but yeah, this is going through all the categories that we've spoken about in computing. I'll give you a minute or so to have a look at it, and then we'll move on. Cool, are we ready to move on?
Yeah, you can go on.
Oh, 1 second.
Yes, I'm done, Mr. Hamza.
The conclusion is that mathematical functions and equations play an integral role in computing by enabling systems to perform calculations, process real-world data, and solve complex problems, whether through predefined functions in code or custom-built formulas. These tools allow for accurate modeling, simulation, and decision-making. Understanding how to implement these functions and equations ensures precision in programming and efficiency in system performance, making them essential skills for every computing professional. Now, just to go back here, I've not spoken about this sign, but just to make it clear to you guys, this just means the sum of. So in this example, it would mean the sum of x divided by n. And here would be the sum of x minus mu squared divided by n. So just don't get confused by that. Don't worry about it. It just means the sum of. Uses algebra to solve computing equations. Algebra is a fundamental branch of mathematics that deals with symbols and the rules for manipulating those symbols. In computing, algebra is commonly used to formulate and solve equations that represent real-world problems. These equations often involve variables that represent unknown values, which need to be calculated or manipulated to support decision-making, system modeling, or data processing. Algebra allows computing professionals to abstract problems into mathematical expressions, which can then be solved manually or programmatically. Yes, it is especially useful in software development, data analysis, graphics, cryptography, and performance optimization. In computing, algebra is used to rearrange formulas to isolate a variable, solve for unknown in a software algorithm, model relationships between variables, simplify logic for programming conditions, calculate unknown parameters dynamically in real-time systems. Example 1, solving a simple formula. The scenario here is that a program calculates the total cost of a purchase using the formula total cost equals unit price times quantity total cost, quantity, sorry. So unit price multiplied by quantity. If a customer's total cost is £120 and each item costs £15, algebra can be used to solve for the quantity. So for this example, you would substitute the values in. The total cost is 120, each unit price is 15. So then we would divide the unit price to get the quantity. So 120 divided by 15 equals 8. So the quantity here would be 8. Application in computing is this equation could be used in shopping cart function to back calculate how many items a user has purchased given a fixed total and known unit price. A formula, so rearranging a formula in a program. A formula is used in a performance monitoring tool. Speed, time equals distance divided by speed. Yeah, so time equals distance divided by speed. If the time taken and distance are known, but speed is unknown, then speed equals distance divided by time. Given that the distance is 500 kilometers and time is 5 hours, solution would be speed equals 500 divided by 5, which is equals 100 kilometers per hour. The application in computing is that this might be used in a logistic software system to estimate travel speeds for delivery vehicles or to optimize route planning. Solving for missing value in the tax calculation. So the formula here would be total price equals net price. Add the net price times VAT. To find the net price, we rearrange this. So total price equals net price, add 1 plus VAT. If the VAT is 20% and the total price is 120, we will substitute the values in, which would be 120 equal net price multiplied by 1.20, which would then rearrange to net price equals to 120 divided by 1.2, which equals to £100 in this case. The application in computing is that this can be used in accounting software to calculate pre-tax prices from invoices. Example 4 is solving an equation in a linear model. So this equation could be y equals mx plus c, given y is the output, which is 40, m is the slope, which is 5, c is the intercept, which is 10. So substituting this substituting this in to find x, we would do 40 equals 5x plus 10, take away 10, so 5x equals 40 minus 10, which is 30. So and x equals 30 divided by 5, which equals 6. Guys, the answer equals 6. So the application here is that used in machine learning, linear regression, algorithms to predict input values when outputs are known. Here's a little summary of examples of algebra in computing that I've just spoken about. I'll give you a minute or so to have a look at this, and then I think we might be done.
Yes, Mr. Hamza, I'm done.
The conclusion is that algebra is a crucial mathematical tool for solving equations in computing. By applying algebraic manipulation, such as rearranging formulas and isolating variables, programmers and system analysts can create more adaptable, accurate, and efficient systems. Sorry. From financial applications to machine learning and data modeling, algebra is at the heart of problem solving in the computing domain. Here are some of the references for today. It'd be good to have a look at these for your further reading. Again, repeating like last week, any queries, questions, kindly either email there or ask me in the group chat or privately. Refer to the ebooks and journals on the Moodle on Moodle for this unit. Further reading is crucial again, and the assignment submission is after 2 weeks of the completion of the units and its delivery. But yeah, guys, that is it for today. If you have any questions, let me know. Otherwise, you guys are free to go. Thank you and have a nice day.
Thank you.
Thanks, guys.
Okay, thank you.
Thank you.